All right. Hey, Jakila. We're recording this for you. All right. So the rest of Chapter 8, we've done 8.6. That's what your homework was on, and I'll answer any questions you have about that. We'll keep going. Then today we're covering 8.7. Tomorrow we'll cover 8.8. And then 8.8 has a bonus section. So a lot of them will have that, but we don't do it. But this one's really important. So we're doing 8.8 one day and then 8.8b the second day, which will be Wednesday block day, because it's actually a pretty hard section. So we're giving the whole block day to that bonus part. Then Friday we will review the entire class period, and Monday is your Chapter 8 test. And remember, if you do better on this test than the mid-chapter, it replaces. Okay? Any questions there? All right. Do y'all have any 8.6 questions that you would like to see from the homework? If not, we can start trucking on to 8.7. Okay? We're what now? The degrees positive? Like,
he's
all...
asking, like, when you check them, like, what was the, like, when you had to check your answers, when, like, if the degrees, like, even or something, you had to check it?
Yes, if it's even root. Yeah, so I see what you're saying. Degree is always positive. That's why I was confused about your answer, because, like, something has to be degree 0, 1, 2, 3, or 4, because it's the highest power. So,
is it a fan on or something?
Yes, it is. So I'll turn it off. It's blowing everything. So if there is an even root, like a square root, a fourth root, which would also be a 1/2 power or 1/4 power, if there's ever any of those, you do have to check your answer, because you can't take the square root and get a negative, or the square root of a negative unless you're doing imaginary numbers. So yeah, that's the answer to that question. But do y'all have any of the actual homework problems you'd like to see? Are y'all good? All right. So today we're doing 8.7, which is the composition of functions. Okay. Somebody gave me this visual for a function one time, and let me see if this helps you. Okay? So let's say that you have a box here. Okay? And this box has a slit on one side. And a slit on the other side that we can't see because of it being 3D. Okay? So if this box is a function, we'll call it f of x. You feed the box an input. Inside that box, it does something to it. Sometimes we know what it does. We have the rule. Like if it were x squared plus 1. Everything you fed it, it would square it and add 1 to it and spit something out, right? So the input, then f is the rule to whatever it does the input, and then it spits it out, okay? And I made it a box because sometimes you don't know what the rule is. They'll just give you a long list of ordered pairs, and they tell you, like, every time that you plug in 1, you get a 7. Every time you plug in 2, you get 15. And you don't know what the rule is. You just have a list of inputs and outputs, okay? Well, what happens when you have composition of functions is you have two function boxes. We'll call this one g of x, okay? It has a slit there and a slit here. Okay? So likewise, you can feed it input, it'll do something and give you an output. Okay? Well, composition means that you take the two functions and you slide them together so that you now have this. So you see what happens now? You plug an input into F, it does the rule, it spits it out here, but it immediately becomes the input for G, and then you have a final output. That's what composition of functions are. You have one function, and sometimes they can line 3 or 4 of them up, okay? You have one function that takes an input, gives you an output. Then you take the output of that function and make it an input into the next function. And if there were a third one, you would take the output there and put it in to the next one and get a final output, okay? So visually, that's kind of what's going on, okay? So let me give you an example. So let's say that f of x is 3x plus 2, and g of x is x squared minus 3. Okay? Well, there's 2 ways you can write compositions, and your book actually does both of them, so I'm going to show you both. One, they could ask you, what is f of g of 1? Or they could write it like this. Those 2 things mean the exact same thing. This means f of g of 1. This means f of, little circle O, a little circle means of, f of g of 1. Okay? So what would be our input here? What's the original input? No, that's an output. The original input in this example is 1. You're going to take 1, and what does it get input into? 1 gets into G first, right? So, and this is just like order of operations. With all the parentheses, you start on the inside, okay? So the first thing that happens is we plug 1 into G. So this is what the original equation would say, or the original question. If f of x is this and g of x is that, find f of g of 1, or they could also word it this way too, find f of g of 1. What I always do is if it's in this form, I immediately write it this way, because this way makes a lot more sense to me, okay? So the first thing we're going to do is find g of 1. Well, g of x is x squared minus 3. So g of anything is anything squared minus 3. So what would g of 1 be? 1 squared minus 3, which is negative 2. So what this says is when 1 is the input into g, the output is negative 2. So in place of g of 1, what can we write? Negative 2. And this now becomes f of negative 2, which everybody can do. What would that be? F of anything, yeah, well, back up. How'd you get that? F of anything is 3 anything plus 2. So f of negative 2 is 3 times negative 2 plus 2, which would be negative 6 plus 2, which is negative 4. And that would be your answer. Okay? Visually, what that would look like, and you'll never have to draw this, but I want you to see what's going on, especially for those of you that are visual learners. One day, if we have some extra time in class, I would love to give y'all a learning styles inventory and see what type of learner you are. Because if you know that, then you can cut your study time in like half. If you know if you're a visual learner or an auditory learner or kinesthetic or reading, writing, okay? Because whichever one is your primary one, if you study in that way, you study way more effectively. And so that's what I used to do before I came here, is I ran a tutoring. There's a test. And so I would love to, it only takes like 15 minutes. I want to try to fit it in. Maybe the block day this week, we can do that, okay? Sorry, Jakala, I got off track. Okay, so what's going on here is, if this is the input, what function is this box? G. Okay, and what got input to that was 1. Well, what came out the other side? -2, right? So in that little box, you have a -2 that comes out. -2 is now the input into f of x, and the final output was -4.
Okay, so it don't have to be like f of x going then the next input for g of x. So it could be either way. G of x come first.
Well, it had to in this case. Now, you couldn't do f first in this one. If you were supposed to do f first, well, actually, let's do the next one. So, example 1. What now? No, this is new. Okay. So now, example 2, what if I ask you to find g of f of 0? Now, in this case, which box is first?
F.
Right. F is the first thing that gets something plugged into it. Then that output becomes the input for G. Okay? So the first thing we're going to say is f of 0 is 3 times 0 plus 2, which is 2. So in place of f of 0, we can write 2. Then g of 2 would be what? 2 squared minus 3, which is 4 minus 3, which is 1. So g of 2 equals 1. So g of f of 0 equals 1. Okay? The only way this gets any harder is, let's say that I wanted you to find f of g of a lot of different numbers. I wanted you to find f of g of 1, f of g of 2, f of g of 3, f of g of 4, f of g of 5. Well, if you did it over and over and over, you would start to see a pattern and wonder if there was a shortcut of doing it instead of doing it into every one every time. And there is. So example 3, what if I ask you to find a formula for f of g of x? Well, the original f of x is that, g of x is that. Okay? So the input this time is just x, right? And what does it get input into? I don't know what the past tense of input is. I don't know if it's inputted or inpat. I don't know. So what was the input for g of x? This is the best way for me to say that. X, okay, and it got plugged into g. So in place of g of x, we could write x squared minus 3. Because no matter what you plugged into g, what it would spit out would be that squared minus 3, right? So now we want to plug x squared minus 3 into f, right? Because the output of g needs to become the input for f. So f of x is 3x plus 2. What is f of c? If I ask you to find what is f of c? 3c plus 2. What's f of Alabama? 3 Alabama plus 2. Okay. F of purple? 3 purple plus 2. Okay, f of anything, 3 anything plus 2. So what's f of this junk? 3 times this junk plus 2. Right? Now that's a very technical math term that y'all just heard. Okay, this junk, right. So then you're just simplifying with algebra. You distribute the 3, so that's 3x squared minus 9 plus 2, which becomes what? 3x squared minus 7. So what this is saying is, instead of plugging in every different x and getting an output for g and then plugging that output into f and getting a new output, you could just plug it into this equation. So let's see if it checks out. The first thing we said was f of g of what? 1. And we figured out that f of g of 1 was -4, right? Well, let's see if that's what we get when we plug a 1 in here. F of g of 1 would be 3 times 1 squared minus 7, which is -4. So what we did the first time, if they ask you what composition is of just one number, it probably is easier just to plug that number in, get an output, plug that in. But if they want a rule, or if you're doing it for like 10 different numbers, it's best to find the rule for f of g of x and then plug in the specific inputs that you want. Okay? So what this is saying is, if you take any input, plug it into g, take that output and plug it into f, and get a final output, it's the same as just taking 3 times the original input squared minus 7 every time. Which, that's pretty crazy, right? Let's do another one to make sure everybody's on board. Okay, so let's say I gave you if f of x is x squared, we'll say 2x squared minus 5, and g of x is 4 minus x, I want you to find 3 things. Okay? See what y'all can do with these 3, and I'll bail you out in a couple minutes. Kyle, this would be a great time to take a bathroom break if you need one. Got that, Chris. 1 second. Chris needs me to print something. All right, Chris is printing right now. Okay?
Should we? Oh, right, like this. Like if we have some square, we should write like that. This rather than this. What?
Was it like x squared and you're supposed to plug in a 2 or negative 2 or something like that?
Yeah.
Yes, then that one that's on the right is correct.
Oh.
Because if it were negative, you would need to have the negative squared as well. So that's where it would change. Okay. All right. So let's see what we got. What do I plug in first for this one? Right, so g of x is 4 minus x, so g of 2 would be 4 minus 2, which is 2. So in place, I can say that f of g of 2 is the same as f of 2. In place of g of 2, I wrote a 2. Well then f of 2, f of anything is 2 times anything squared minus 5. So f of 2 would be 2 times 2 squared minus 5, which would be 2 squared is 4. 4 times 2 is 8, minus 5 would be 3. So f of g of 2 is 3. Okay? Now what about this one? First thing I would do if I were you is rewrite it into this notation, because this notation makes way more sense to me. Okay, so how could I rewrite it?
G of f of 1.
G parentheses f parentheses 1. Right, g of f of 1. So first thing we're going to do is plug in a 1 into f. So f of 1 would be 2 times 1 squared minus 5. So that would be 2 minus 5, which is negative 3. So in place of f of 1, we can write negative 3. Then it's simply g of negative 3, which is 4 minus negative 3, which is 7. Okay, everybody following? All right, so what about here? We don't have a number input, we have a letter input. So we're going to input x into g first. Well, that's what g was given to us. When you input x, the output is 4 minus x. So when you input x, g of x becomes 4 minus x. Then 4 minus x now becomes the input into f. Well, f of anything is 2 anything squared minus 5. So f of this is 2 this squared minus 5. Now we have some simplification to do. Do not distribute a squared over a sum or a difference. You cannot say that that is 16 minus x squared or 16 plus x squared. What do you have to do instead?
You have to write it out.
Write it out and FOIL it out. So it's 4 minus x times 4 minus x minus 5. So that becomes 2 times first gives you 16. Outside gives you 4 times minus x is minus 4x. Inside is also minus 4x. And last is plus x squared. Close that parentheses, then you got a minus 5 out here. Okay? Then becomes, we can simplify the parentheses, and we've got 2 times 16 minus 8x plus x squared minus 5, right? Then we distribute the 2. 2 times 16 is 32, minus 16x plus 2x squared minus 5. What's the only thing left? 32 minus 5 is 27 minus 16x plus 2x squared. That is f of g of x. Now, let me say one thing, then I'll answer your question. That's right, I won't count it wrong, but technically, for the best answer, you should put it in standard form. And so that would be, they have to be in decreasing degree, so you would put the squared first, then the linear term, then the constant. Okay? And sure enough, back up here, we wanted to know what f of g of 2 was, and we got 3. If you did f of g of 2 now, they say the rule is 2 times 2 squared minus 16 times 2 plus 27. Well, 2 squared is 4. 4 times 2 is 8, minus 16 times 2 is 32, plus 27. 8 minus 32 is negative 24 plus 27, which does in fact give you 3. Okay? There's one way this can look a little differently and one way that it can get harder. But after that, that's this entire section. Okay? So, I was checking part A. I wasn't checking part C. Because what I was saying is we came up with a rule of f of g of x. So we could have used that rule here and see if we got 3. Because what we did here is we plugged 2 into g and then plugged that output into f. This says you could use this formula instead of having to do 2 separate outputs. Okay? All right, so what if I gave you this? No. Are you? You are cold? Y'all can turn the air hotter if you need to.
No, I don't want to be hot. Please don't.
Okay? So this is one of the ways it can get harder. And the other way looks harder, but it's actually pretty easy. This one is kind of hard. Okay? What would you do first here?
Right.
As what? F parentheses, G parentheses 2, which is, because technically both of these say F of G of 2. So if you say that, I don't know which one you're talking about. Okay? Now, what does this mean? This means that the function f, when the input is 1, the output is 2. So you could have this, like x and f of x. 1 is 2, 3 is 4, and 5 is 4. Okay? Then you could also have a chart for x and g of x. When the input is 2, the output's 5. When the input is 4, the output is 3. So here we don't know the rule. We don't know if it's squaring or what. We don't know what it's doing. But we know that When you plug in a 1, you always get 2. When you plug in a 3, you always get 4. When you plug in a 5, you always get 4. When you plug in a 2, you get 5. When you plug in a 4, you get 3 in this function. So, this should have been a 2 right here, sorry, instead of x if you were copying me. So, what do we plug into what first? Plug what into G? 2. So what is G of 2? 5. When 2 is the input for G, the output is 5. So in place of G of 2, we can write 5. Now what is F of 5? 4. Therefore, F of G of 2 is equal to 4. Okay? So, I wrote these two close together, so I'm going to cross this one out and do it on the next page. But, okay, so now we're not wanting it for a specific x, we're wanting it for all x's. Okay? So, what function gets plugged into first when it's written this way? G. So, the domain of this composition, what does domain mean? Well, it means more than that. Domain means possible inputs. It's not always x, but so domain of any function or composition of function is all the possible inputs. Well, whatever we choose as an input, we have to plug it into G first, right? So what are our only options for input of this function? 2 and 4, okay? So what we're going to do is we're going to make a t-chart of x and f of g of x, okay? And we know the only two inputs are 2 and 4. So first we're going to find f of g of 2, which actually we already did. It's 4, right? So when the input is 2, the output of this composition is 4. Okay, right? What about when the input is 4? So the first thing you're going to do, we're trying to find that when the input is 4. So the first thing we're going to do is find f of g of 4. We plug 4 into G, and what is our output? 3. So in place of g of 4, we're going to write 3. Now we want f of 3, which is what? 4. So f of g of 4 is 4. Okay? So if I ask you to find what f circle g is, you would list it like this. Because we don't know the rules, we only know ordered pairs. So for f circle g, we know that when you input a 2, you get 4, and when you input 4, you get 4. And those are the only 2 points on that function. Okay? Now let's find G circle F. Okay? So ignore that. Okay. So part C, I'm going to ask you to find G circle F. Okay? So what I would do first off is write it as G of F of X. Okay, so in this case, what does X get plugged into first? F. So for this relation, this composition, the domain of this composition is actually the domain of F, because whatever you plug into F is what gets you started. So you can't choose any numbers that weren't in the domain of F. What is the domain of F? 1, 3, and 5. So all we've got to figure out is, at 1, 3, and 5, what is G circle F? So the first one would be, what is G of F of 1? So do we need to do F of 1 or G of 1 first? f of 1. We can't do g of 1. We don't know what it is. But you start on the inside. So what is f of 1? Brittany, I heard you say it. 2. So in place of f of 1, we can write a 2. And now we need to find g of 2, which is 5. So when you plug 1 into f and plug that output into g, your final output is 5. Okay? So now we need to do g of f of 3. So the first thing we're going to do is plug 3 into f, and what is our output? 4. So now we need g of 4, which is what? 3. So that says if you take 3 and plug it into f, and then plug that output into g, your final output is 3. So what is the last thing I need to figure out?
G of 5.
G of f of 5. Okay. Well, what do we plug into what first? What's the original input and what functions does it go in? What goes into F? 5. The original input is 5 and its input into F. What is the output when the input to F is 5? 4. Now what is the output to G when the input is 4? 3. Therefore, if you're supposed to list G circle F, it is 3 ordered pairs. When the original input was 1, the final output was 5. When the original input was 3, the final output was 3. When the original input was 5, the final output was 3. That's your answer. Okay? All right. 2 more examples. Well, 1 more example maybe. Okay, so let's say that if f of x is 2x squared minus 3x and g of x is 1 minus x, what if I ask you to find that would be f of x. So what does that mean in English?
Just f of x?
No. What would be the original input?
F.
No. X. The original input is x and it gets plugged into f, right? Then we're going to get an output. We put that output back in and run it through again.
What's the point of G?
Was just to throw you off.
So,
Okay.
So wouldn't it just be f of x though?
Nope.
No,
Because, okay, so when you plug in x to f, what is your output?
2x minus 3x.
2x squared minus 3x. So in place of f of x, we're going to write 2x squared minus 3x. F of anything,
Wow.
f of anything is 2 anything squared minus 3 anything. So f of this junk is 2 times this junk squared minus 3 times this junk. Right? Everybody see where that came from? F of anything is 2 anything squared minus 3 anything. So f of this is 2 this squared minus 3 this. Okay, now you just have to simplify. This becomes 2x squared minus 3x times 2x squared minus 3x minus 3 times 2x squared minus 3x. This we have to FOIL. 2x squared times 2x squared is 4x to the 4th. 2x squared times minus 3x is minus 6x to the 3rd. Minus 3x times 2x squared is minus 6x to the 3rd. Negative 3x times negative 3x is plus 9x squared. Then over here, you got a minus 3 that you get to distribute. So that's minus 6x squared plus 9x, right? Here we have two like terms that we can combine. 4x to the fourth minus 12x to the third plus 9x squared minus 6x squared plus 9x. Lastly, we're just going to distribute the 2. That's 8x to the fourth minus 24x to the third plus 18x squared minus 6x squared plus 9x. Is there anything left? Combine those two. So it'd be 8x to the fourth minus 24x to the third plus 18x, or no, so plus 12x squared plus 9x. Okay. So your homework is, one second. What is today? Here we go. There's your homework. Can y'all see that?
524.
524, 21 through 24, 27, 29, 32, 34 through 36, 41, 42. Yes. Just like, bring them up here.
I have to do the discussion thing.
Uh-huh.
I usually do it after school, but she doesn't have any school class. Can I do it Wednesday during this?
Yeah.
Just go on holiday.
Yeah, no problem at all.